Today we're going to learn how to use an area model to solve a multiplication problem. An area model is arranged in rows and columns similarly to an array, but there are no spaces between the symbols. So here's our problem. The school assembly room has 5 rows of chairs with 20 chairs in each row. If the third grade classes fill 3 rows of chairs, how many third graders are at the assembly? So first we have to figure out what we need to find. I see the question says, if the third grade classes fill 3 rows of chairs. So I know I have 3 rows. And up above it says that all of the rows have 20 chairs. So I'm going to use the factors 20 and 3. Okay? So if you think back to earlier in the year, we learned about how a rod represents 10. So there's 10. And if I put another rod down, that equals 20. And I'm going to move them over so that they fit in the screen. So here's 10 and 20. There's one row. Here's another 10 and 20. That's 2 rows. And here's our third 20, 3 rows of 20. Okay, so my rods represent the seats in the assembly room. Now I'm going to trace around my rods to make my area model. This is the area that is being filled by the seats. I'm going to connect along the top here. Okay, so now we can take a look at what 3 rows of 20 represents. Now if you think back to the distributive property, we learned that we could break apart a number. So I'm going to break apart my 20s into 10 plus 10. Okay, so now I'm multiplying 3 times 10 plus 3 times 10. 3 times 10 is 30. And 3 times 10 is 30 again. So if I multiply 3 times 20, I can break it apart as 3 times 10 plus 10. And this is equal to 3 times 10 plus 3 times 10, or 30 plus 30. And 30 plus 30 equals 60. So we have found that there are 60 third graders. Let's take a look back at what we've done here. First, we knew that we had to find how many third graders were at the assembly. We decided to make 3 rows because that's how many third grade classes we filled. And then we put 20 chairs in each row. This complete row is 20, but we decided that we would break 20 up as 10 plus 10 just because it's easier to multiply smaller numbers, as we learned from the distributive property. Then we took the 2 smaller area models and added them together to get a total of 60. So the product of 20 times 3 is 60. That's one problem. Okay, now let's take a look at another problem. This one says Megan is watching a marching band practice. The band marches with 4 rows of people playing instruments. She counts 30 people in each row. How many people march in the band? So for this one, what are we trying to find out? How many people? Up here, it says there are 30 people in each row. And she has 4 rows. So that leads me to the number sentence 4 times 30 equals n. Okay, now the next part, knowing the distributive property, I can break 30 up as 10 plus 10 plus 10. So that's 4 times 10 plus 10 plus 10, or 4 times 10 plus 4 times 10 plus 4 times 10. 3 4 times 10s. Okay, now to find this, we can draw an area model. However, I don't have enough room on my grid, so I'm going to apply the commutative property. Let's see what that looks like. Okay, with the commutative property, I can change the order of the factors to 10 times 4, like this. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, let me move it up so it fits on our screen here. Is it moving? There we go. I'm going to move my camera over here for you. Okay, and I'm going to do 4 of these, like this. This is 10 rows of 4. And 10 rows of 4, if I trace this area model, that's what 10 rows of 4 looks like. It equals 40. And I'm going to do this right over the top here and do it again. 10 rows of 4 again. And again, 10 rows of 4 is 40. So I have 1, 2, I need to do one more. 10 rows of 4. And I'm just going to go around my number sentences here. Okay, so my area model looks like this. 10 rows of 4. And I did it 3 times. Okay, so I have 40 plus 40 plus 40. 4 plus 4 is 8. 8 plus 4 is 12. But we're in the tens place, so that's 12 tens. Whoop, let me move this over. 12 tens is 120. So there are 120 people in the marching band. Let's take a look at how we figured it out. From the problem, we knew we needed 4 rows of 30, but I didn't have enough room on my grid paper. So I broke 30 up as 10 plus 10 plus 10 and multiplied that by 4. And I multiplied 4 times 10 once, 4 times 10 twice, 4 times 10 3 times because of the distributive property. But again, I did not have enough room on my grid paper to do 4 times 10 this way, so I used the commutative property to do 10 times 4 because I did have enough room to do it this way. And I did 10 times 4 3 times. Then I added the products, 40 plus 40 plus 40, and I got 12 tens, which is 120 people. So 4 times 30 equals 120 people. It's another way of thinking about using an area model. And this time we used two properties of multiplication, the distributive property, breaking a factor into smaller parts, and the commutative property, changing the order of the factors so that the area model would fit on our grid. Okay, when you come to school tomorrow, we're going to try it on grid paper in school.